Hi, a very good morning to my panel, Cik Muhammad Fazli, and I are Dr. Buniman Azali. So, introduce myself, my name is David Telungwe, CE190146. So, this is my presentation for final year project 1. So, my title is Deployment of Skeleton Hand for Paralyzed Finger. So, my supervisor is under Prof. Naya Dr. Jamaluddin bin Jalani. So, next slide is my project background. Is the human hand is the most compatible part of the human body and allow people to interact with the environment, including daily activity. So second point is a problem with the nervous system cause paralysis. If the nervous system is damaged, can risk the muscle. Stroke and spinal cord injury are the leading cause of the paralysis. So it is important for paralysis patient to apply a skeleton hand for grasping and grasping rehabilitation therapy. So my problem statement for this project is first is common cause of paralysis including stroke, spinal cord injury, and nerve disorders such as multiple sclerosis. Second is the paralyzed finger stop the patient from performing grasping and ungrasping activity. In this case, the motor function of paralyzed finger require repetitive therapy to make them move again. Last point is in this project, an attempt to develop the skeleton hand for the paralyzed finger is proposed. This hand will be equipped with a stable motor for execution and practical controller for optimum response during grasping and ungrasping. So my objective for this project is first is to design and develop a skeleton hand for paralyzed patient. Second is to apply a stable actuator motor to grab and ungrasping. Third is to apply suitable controller for grasping and ungrasping. So next is my scope of work. This project is focused on finger rehabilitation, and this project use SolidWorks software and MATLAB as well for design and application. The complete design will convert the SolidWorks file to 3D printing. So last is the rehabilitation therapy of grasping and ungrasping for paralyzed finger. So this is my methodology flowchart. As you can see here is from start, and we do the literature review and identify the suitable design, choose the best design for skeleton hand that I need to design, and next step is design and develop a suitable skeleton hand using SolidWorks software, and then doing the simulation of design skeleton hand by using SolidWorks software, then to apply the suitable actuation motor and the controller for skeleton hand system, and last to get the result and analysis the result and so next this is my full view of hand design. Yeah, that I need to show that in the SolidWorks program. So this is the design. As you can see here, this is a regular link to connect the support link of this, and the connecting link to the motor gear suspend. This is motor, this is gear, and this is the board of circuit with a motor hole here, and this is the palm layout design, and then so this is for finger mouth layout design, where this hole we can insert the string for velcro string to tie into our finger, and as well you can move along with the when the motor move, we can the finger will move when the motor is in running condition. Then this is the motor layout assembly design. Then this also design of triangular link layout, and the shaft layout design. This is the shaft layout design. This to connect the finger mount. And then this thing that connect all this part, that I call is actual linkage layout. Then I'll show it from this is from the top view that we can see. This is the palm of hand, and this is the board of circuit, and this is the gear they connect to the motor, and it move the connecting rod and connect to the triangle link. This is this is from the right view. As you can see, this is the motor, this is the gear suspension, this is the connecting ring, supporting link, and this is the connecting link 1, this is connecting link 2, and this is supporting link also, and this is triangular link, and this is the finger mouse, and this is finger, and this is the finger that connecting. Then for the simulation, where we need to see it crisping and ungrisping, I set it to the motion study, and we can see when the motor move, the gear suspension, we move the support link and the connecting link to the triangular link, and then all the 4 finger we move all together. So that's all for my simulation and the design and 3D design. And this is all the assembly design that need to connect all together. And then continue to my slide. For the expectation result, the model of skeleton hand will be able to help paralyzed patient with rehabilitation therapy. Second is patient can also use the model of skeleton hand at home in longer and more extensive season, giving more rapid improvement to the paralyzed finger. The component of the skeleton are 3D printed, and this makes it a low cost and easy to replication and customize the design. So that's all for my presentation. So thank you very much.